Hello again. This is the video content for Monday, May 10th. I appreciate all the time that you've been putting in to keep up with organic chemistry. I'll remind you in this video of the quiz format, and then I'll go over some of the insights into answering the questions on homework sheets 4 and 5. I will talk to you here during the first period of the double period on Monday, and then you'll take the quiz in a folder in Schoology that will only open up for the second of the 2 periods on Monday. You'll have to complete that quiz within that period of 4th period or, let me think. It would be 3rd period or 5th period, depending on what class you're in of mine. All right. This is the format of the quiz. There are going to be 16 organic reactions. You'll have to give me the type. I'll list the reactants in words. You'll have to give me the name of the product, and occasionally you'll have to give me the structural formula of the product. Here's a suggestion for how to prepare for the quiz, and I would have given you this earlier in an email so that you can perhaps do it over the weekend. There is an orange sheet that I've given you that's a practice quiz. You might go through this orange quiz and write in simple sample reactions that you can find by looking through this study guide that I've posted in Schoology. This is an excellent study guide to study. Write the simple reactants, the simple, the structural formulas of the products and the product names for every one of the reactions that is listed there. So here's what the orange sheet looks like. This is what the study guide looks like. It would be a great way to prepare for the quiz. All right, I'll also remind you that for this quiz also on Monday, you may use your orange card. If you're going to be in class, the sub knows that this is the only orange, this is the purple card, the lavender card. The sub knows that this is the only resource you may use. If you're working online at home, I need to assume that the honesty that you bring to this course is true to the character that I know you have. All right, I'm going to go over some insights on homework sheet number 4 first. I know you can't read this very well, and I apologize for that. Let's look at, perhaps you've got the answer sheet in front of you rather than looking at this screen. For the first one, the complete combustion of ethanol. I've already got the answer here, but let me give you some insights. Instead of writing ethanol, CH3CH2OH, write it as C2H6O. You will have to balance this reaction, and knowing it's a complete combustion allows you to know that only carbon dioxide and water are the products. Here it says number 2 is an addition reaction. That means you've got to have an alkene or an alkyne, and it says it's 2-butene. You may write the structural formula or you may write the condensed structural formula. Either way is fine. But an addition reaction has you taking a molecule, here it says hydrobromic acid, and adding both of those atoms across the double bond, thereby eliminating the double bond and making a new saturated compound. You'll have to name it on the quiz. This is one of the 5 polymerization reactions you need to write. This I highly recommend that you look closely at on the notes that I've given you or on the review sheet. Notice the way we write the polymer. With the monomer, I have to give you millions and millions of them, and so we just use the coefficient N. And then that double bonded that molecule with the double bond in it breaks the double bond, and all the molecules link together in a long chain. So there are N number of subunits from the original N number of monomers that you had. You need to know 5 of these reactions. Here, you've got the oxidation of ethanol. You should know that ethanol is what kind of an alcohol? Primary, secondary, or tertiary? Based on which of those answers you say, you know whether this reaction goes to an aldehyde and a carboxylic acid, or to a ketone, or doesn't occur at all. You need to look closely at the process that you use. If you're distilling, you are not going all the way to the complete final product of oxidation. That requires refluxing. So if this is a primary alcohol and you're refluxing, you would only go to an aldehyde for the product. Esterification should come quickly to you. An acid and an alcohol makes an ester and water. Don't forget the water as your second product. It will cost you points. There's also a wonderful ester formation review on the very last page of the class packet from the first unit of organic chemistry. It would be the last page of the hydrocarbon and functional group class packet. Look at that for ester practice. Saponification, you just need to know the reactants and the products. You rarely have to write them out. Electrophilic substitution. Remember, any of these substitutions are where you take one element or part of a molecule off and you put another group or atom on. So electrophilic substitution is always going to be about benzene. You need to look at the types of electrophiles that we'll be using to add on to the benzene ring. These are very nicely delineated in the study guide, the study packet. That is a new resource that I posted. So here you put the NO2 on and H2O goes home as the second product. On the back of this homework sheet number 4, if I say it's here you have to tell me what type of reaction with that triple bond you are going to be taking I'll start again on number 8 on homework sheet number 4. When I see a halogenoalkane, I know it's going to be a nucleophilic substitution. That's where you take the halogen off and you put a different component on where that halogen was. Here your nucleophile is HCN, and so I would take the Cl off, put the CN on, and then put the hydrogen and the chlorine together in the second product. There are excellent examples of nucleophilic substitution in the study guide. That is the new resource that I've posted. All right, looking at number 9. When I see ethene, I see an alkene. When I think of a molecule with a double bond, it makes me go to an addition reaction. With an addition reaction, you're going to add both components of the second reagent, chlorine. So you'll put both chlorine atoms onto and across that double bond, giving you a saturated molecule, one product for your answer. You'll have to write it and name it. Here I have another halogenoalkane. It reminds me of number 8. Once you see a halogenoalkane, you know that it's going to be a nucleophilic substitution. Another double bond. This makes me think of number 9 again. With number 11, you have an alkene, and that alkene will undergo an addition reaction where the HCl puts both the H and the Cl onto the molecule, breaking the double bond. Remember, you get one product. With esterification, you need to know how to link those two molecules together. Remember, the functional groups are the active component. There is excellent practice on the very last page of your class packet from the first unit in organic chemistry. If you go back to your class packet on hydrocarbons and functional groups, that class packet has a whole page of practicing writing the names and structures of esters. You can find the answers on Schoology. Don't forget that there are two products with esterification, the ester whose name you have to nail, and water. Finally, number 13 gives you methane. That's an alkane. There's only, besides combustion, there's only one very slow reaction that an alkane can do, and that is alkane substitution. This is different because first, you need to know that UV light is required. It's not an easy reaction to occur. Second, you only take one hydrogen off of the alkane and you put one of the atoms of the halogen onto the alkane. So notice you have two products. The next homework sheet, number 5, is also having you write reactions, just a little bit of insight into this. If you're using 1-chloropropane and sodium hydroxide, that says nucleophilic substitution. You've got a halogenoalkane. You should be able to write that out in either a structural formula or a condensed structural formula. You cannot use a molecular formula. And you can see where the Cl comes off, the OH goes on, you make an alcohol, and the NaCl as a second product. An addition reaction, you don't need to know that sulfuric acid is a condition that's necessary, but you do need to be able to break that double bond, and with water as your reagent that's adding across the double bond, you put the H of the water on one of the carbons and the OH from the water on the other, hence making an alcohol. All right, this requires some thinking again. 1-propanol. Is that a primary, secondary, or tertiary alcohol? That will tell you what product you get. What's your condition? Here you're refluxing, which means you'll go as far possible as you can with the oxidation reaction. So 1-propanol is a primary alcohol. This notation is telling you that it's an oxidizing agent. That O in brackets is an oxidizing agent. It could be potassium permanganate, it could be potassium dichromate. You don't have to worry about that. But nor do you have to know these conditions. You just need to know what happens with refluxing and distilling. So with refluxing, you go all the way with your primary alcohol to carboxylic acid and water. Fermentation takes sugar with enzymes from yeast, and you get alcohol, ethanol, and carbon dioxide. Amide formation is parallel to esterification. You can study this. Alkane substitution using ethane. Once again, notice that saturated alkane. With an alkane substitution, you're going to take just one H off and put one of the Br atoms on, giving you two products. I hope this is becoming more apparent to you. With addition polymerization, here's another one of the 5 where you have to know what this monomer is and know how to hook it together using this symbol of the bracket with an N as a subscript for the polymer. A few more on homework sheet number 5 on the back. Alkane substitution. Once again, a saturated hydrocarbon. You take one H off, you put one chlorine atom on. Hence, you get two products. Combustion. You need to be able to write pentanol in a convenient way to balance this equation. When you see this double bond, you know it's an addition reaction. Another one of the 5 polymers that you need to know. The esterification reaction, that you need to write and name the product. Finally, fermentation gives you ethanol and carbon dioxide for products. So this is the end of the video that you will be watching the period before, or perhaps earlier, than the period in which you take the quiz. Good luck with the quiz. I hope you've studied the study guide. Remember to come back Tuesday for another video that you can watch in class if you're here in class, or you can watch at home anytime then. Thank you.